Imagine a simple task. Picture yourself sitting comfortably, perhaps with a cup of coffee in hand, ready to engage in a quick mental exercise. You see the word red printed in blue ink. Your brain processes the word and the color almost simultaneously. Your job? Name the color of the ink blue? Easy, right? It feels almost automatic, like a reflex. Now try it again with the word green printed in red ink. This time your brain has to work a bit harder. This time you need to say red. But wait. There's a moment of hesitation. Suddenly it's a little trickier. Your brain is caught in a brief conflict. You might even hesitate or say the wrong word entirely. It's a curious phenomenon, isn't it? This, my friends, is the Stroop Effect in action, named after John Ridley Stroop, who first described it in the 1930s. This seemingly simple exercise reveals a fascinating conflict within our brains. It shows how our cognitive processes can sometimes clash. It highlights the difference between automatically reading a word and consciously identifying a color. These are two distinct processes that our brain handles. This clash between two processes, one effortless and the other requiring focus, is what makes the Stroop Effect so intriguing. It's a small window into the complexities of our cognitive functions, reminding us of the intricate workings of our minds. The Stroop Effect is named after American psychologist John Ridley Stroop. Born in 1897, Stroop was a pioneer in the field of cognitive psychology, dedicating his life to understanding the intricacies of human thought processes. In 1935, he published a groundbreaking study that first demonstrated this phenomenon. His work was conducted in an era when the field of psychology was still in its infancy, making his findings even more remarkable. Stroop presented participants with lists of color words, but with a twist. Instead of simply reading the words, participants had to name the color of the ink in which the words were printed. Sometimes the words were printed in the same color they spelled, known as the congruent condition, where the task was relatively straightforward. And other times they were printed in a different color, the incongruent condition. This created a conflict between the word's meaning and its ink color, challenging the participants' cognitive processing. Stroop's findings were clear. People were significantly slower and made more errors when the word and its ink color clashed. This delay and increase in mistakes highlighted the difficulty our brains face when dealing with conflicting information. This simple experiment revealed a fundamental principle of human cognition. Our brains struggle to process conflicting information. The Stroop Effect has since become a classic example in psychology, illustrating the complexities of attention, perception, and cognitive control. It continues to be a valuable tool for researchers studying the human mind. The Stroop Effect illustrates a battle between two cognitive processes. It's a fascinating phenomenon that reveals the complexities of our brain's functioning. On one hand, reading is an automatic process for most adults. This automaticity comes from years of practice and exposure to written language. We've been doing it for years, and it requires little conscious effort. Our brains have become so efficient at reading that we often don't even realize we're doing it. When we see a word, our brains instantly decode it and access its meaning. This rapid processing is a testament to the brain's incredible ability to adapt and optimize. On the other hand, identifying colors is a more controlled process. Unlike reading, which has become second nature, color identification requires deliberate focus. It requires focused attention and takes a bit longer. This is because our brains need to process visual information and then interpret it correctly. When presented with an incongruent Stroop stimulus, like the word green in red ink, our brain faces a unique challenge. Our automatic reading process immediately identifies the word green. This happens almost instantaneously, without any conscious effort. Simultaneously, our controlled process tries to identify the color red. This requires more cognitive resources and takes a bit more time. This creates interference as the two responses clash. The brain's automatic reading process and the controlled color identification process are in a tug-of-war, leading to a momentary cognitive conflict. The Stroop Effect isn't just a psychological curiosity. Neuroscientists have used brain imaging techniques to pinpoint the neural circuits involved in this conflict. Research suggests that the anterior cingulate cortex, a brain region involved in conflict monitoring, plays a crucial role. When faced with incongruent Stroop stimuli, this area becomes highly active, reflecting the brain's effort to resolve the conflict. Furthermore, studies have shown that different brain pathways are activated during automatic reading and controlled color naming. This reinforces the idea that these processes, while seemingly simple, rely on distinct neural mechanisms. Section 5. Cognitive interference and selective attention, navigating the information overload. The Stroop effect highlights two fundamental concepts in cognitive psychology: interference and selective attention. Interference occurs when one mental process hinders another. In the Stroop effect, automatic word reading interferes with color naming. Selective attention refers to our ability to focus on relevant information while ignoring distractions. The Stroop effect demonstrates the limits of our selective attention. Even when we try to focus solely on color, the irrelevant word information still seeps through, creating interference. The Stroop effect isn't just a fascinating laboratory phenomenon, it has real-world applications. Clinicians use modified versions of the Stroop test to assess a variety of cognitive functions. For example, individuals with attention deficit/hyperactivity disorder, often known as ADHD, often show greater interference on the Stroop test, highlighting their difficulty with selective attention and inhibitory control. The Stroop test can also be used to assess cognitive function in individuals with traumatic brain injuries, dementia, and other neurological conditions. By measuring response times and accuracy on the Stroop test, clinicians can gain valuable insights into an individual's cognitive strengths and weaknesses. The Stroop effect isn't confined to the laboratory or clinic. It pops up in our daily lives more often than we realize. Ever tried to quickly name the color of a traffic light while chatting with a passenger? The Stroop effect can make this seemingly simple task surprisingly tricky. Similarly, imagine proofreading a document where formatting changes are highlighted in different colors. The Stroop effect can make it challenging to quickly identify the color of the highlighting while simultaneously processing the text's content. Intrigued? You can experience the Stroop effect firsthand. Find a list of color words printed in different ink colors online or create your own. Try to name the ink color of each word as quickly as possible, ignoring the word itself. You'll likely find yourself slowing down and making more errors when the word and ink color clash. This simple exercise provides a tangible demonstration of the Stroop effect's power. It highlights the remarkable capacity of our brains to simultaneously process information, even when it conflicts.